All right, so today we are going to be demonstrating Lab 4, which is basically adding and subtracting two 4-bit signed numbers. I have our test cases listed right here in front of me. We got 9 of them, and I'm just going to go ahead and show me inputting the switches on my board, and I will confirm the output. So I'm gonna set my phone up like this so we can see the board and I can do it hands-free. So our first test case is where A equals 2, B equals 1, and sub equals 1. Sub is gonna be represented by this switch right here. So when it's flicked up, that means that A is gonna be, the equation is gonna be A minus B, and then we'll get our output. So let's go ahead and get started. So we got A equals 2, B equals 1, sub equals 1. So we're going to have 2 minus 1. So we expect on our board to show 1. So A equals 2. It's going to be this switch right here. B equals 1 is going to be 1, 2, 3, 4. It's going to be this switch right here. So that's A plus 2. So 2 minus 1 is 1. And then our next test case is going to be A equals 2, B equals 1, sub equals 0. We already got a little sneak peek of that, so flip this down. We have 2 plus 1, so we're going to get 3. Our next case is going to be A equals 7, B equals 4, sub equals 1. So A equals 7, 1, 2, there's 7. That pertains to these three. B equals 4. So what I noticed is that basically this third one, for some reason, it might just be from my basis board, but when I was making the constraints file, I programmed the third bit of B to be assigned to W13. W13, but it's not working. So instead what we have is, just to show you right here, so 1, 2, 3, 4, these 4 represent A, this is B right here, B, then flip this one, and it's not doing anything, but instead the third bit is going to be represented by this one, so we get 7. Then if we flip this one up, we get 1, negative 1. Also, I should let you know that this LED right here, if it's on, that means that the number displayed on the 7 segment is going to be a negative value. So just for further reference, we are going to just ignore this one. I will figure out why that one's not working in future labs, but I've tried to reprogram my constraints file 3 times now, and I'm just going to ignore it because for right now, I'm just going to ignore it because my board works fine otherwise. So W14 will be ignored. B is going to be represented by these 4 switches. The one in the middle, just ignore it. So back to our third test case. We have A equals 7, B equals 4. Let's just get B set up all right. So 1, 2, 3, 4. B equals 4, that's going to be this one, B equals 4, cool. And we have A equals 7, so it's going to be these first 3. And the display will turn off when it is out of the range, and the range is from -8 to +7. So right here we have 7 plus 4, that's going to be 11, that's obviously out of the range. But if we flip this up, we're going to get 3. So A equals 7, B equals 4. We're subtracting 4 from 7. 3 is our answer, and that makes sense. That was test case 3. Let's move to test case 4. We have A equals 7, B equals -8, and sub equals 1. So we keep that up. We keep A equals -7, and we are going to flip this up. So we have 7 minus -8, that's going to be a +15. That is out of the range, so it makes sense as to why our 7 segment display is not working. So that is good. Move to test case number 5. We have a equals -8, b equals -7, and sub equals 0. So flip that down. Let's flip all these down. A equals -8. That's going to be the 4th pin right here. -8. B equals -7. So that is going to be, skip the middle. B equals -7. 2, 3, -7. Or no, that's -8 right there. And to make it a -7, we're going to flip the switch up. So we have A equals -8, B equals -7, sub equals 0, which is basically -8 -7. That's going to be -15. That is out of the range. LED is not lighting up, so that's good. Test case 6, we have A equals -8, B equals -8, sub equals 1. So A equals -8 is going to be, we already have A equals -8. B equals -8. We just have to flip this one down. So we're going to have -8 minus -8. So we expect this to be 0. Flip sub up, we get 0. Awesome. And then we have then for test case 7, we have A equals -8, B equals -8, sub equals 0. So it's going to be -8 plus -8, which will be -16. Flip sub to 0 right here. And we see that the board is not displaying because -16 is out of range. So let's move to test case 8. We have A equals -4, B equals -4, and sub equals 1. So let's just flip these down. A equals -4, that is going to be 8. It's going to be -4. That's good. So we have A equals -4. B is also going to equal -4. So it's going to be this right here. And then sub is going to equal 1. We get a 0. -4 minus -4 is 0. So that is good. And our final test case is going to be A equals -4, B equals -4, sub equals 0. We already have A equals -4 right here, B equals -4 right here, and sub equals 0. We just got to flip this switch down. -4 plus -4 is -8, hence the LED on, meaning that this is a negative number. And that is all of our test cases. So that is Lab 4 demo, and I'll see you guys next week.